While riding a roller coaster, you may feel like anything could happen, which is part of the fun. But in reality, all roller coasters follow the same unbreakable rules of physics to give you a thrill while keeping you safely on track.
What do you like about roller coasters?
Well, I think roller coasters are fairly nauseating.
On a roller coaster, you can feel like a pilot, in the cockpit of a jet fighter, with the G-forces and the twisting and the flipping.
I used to be scared of roller coasters because I thought when you went upside down, you'd fall out. But now I know with the centrifugal force and with the guarding rails and stuff, it's pretty safe.
When I was on a roller coaster, I dropped the penny and I saw it floating in front of my face because it was dropping as rapidly as I was.
Basically, they make me a little nauseous in the beginning, and then they kind of get fun.
They're funny because, you notice that everybody else is really, really afraid. And, for me, I'm not afraid. I'm just really happy and excited that I'm on it.
I especially like the stomach drop after going over a huge hill.
They give you an adrenaline rush, and they're fun to ride.
You get the adrenaline pumping, you get butterflies in your stomach, and then you do it and you're not nervous anymore.
Chills, spills, and thrills are what roller coasters are all about. But no matter how big, how fast, how twisted or terrifying, all coasters obey a few basic rules of physics. The first rule is that the coaster's mass, acceleration, and direction affect how fast it goes. The coaster's lift chain exerts a force on the car as it slowly hauls you up that first terrifying hill. When the car reaches the top, it has all the potential energy it will need for gravity to accelerate it downhill. What is potential energy? Potential energy is the amount of energy an object has due to its position in the Earth's gravitational field, whether it's moving or at rest. Once the chain releases the coaster car, it begins to roll downhill because the force of gravity can now accelerate it. As the coaster falls, its potential energy is converted into the energy of motion, or kinetic energy. Is it kinetic energy that makes you feel so strange on roller coasters? On a roller coaster, the accelerations deliver most of the thrills. The normal acceleration due to gravity is called 1g. When you go down a hill or into the bottom of a loop, the force of gravity pushes you into your seat. You experience positive g's. If you are experiencing several g's, then part of your body, including your blood, feels several times heavier than normal. Not just to you, but to your heart. If your heart can't generate enough force to push the seemingly heavier blood to your brain, it won't get enough oxygen and you'll black out. This sensation creates a feeling of danger. Why do you feel weightless when a roller coaster goes downhill? Inertia, or the tendency of an object to resist change, is playing a role here. When you approach the top of a hill and the car slows down, inertia would send you flying out into the sky if you weren't buckled to your seat. As inertia attempts to carry you up and out, there is less pressure between your bottom and the seat. Your brain interprets this as less weight, and in some cases, as weightlessness. The Viper at Six Flags Magic Mountain is typical of a modern roller coaster. Lots of twists, loops, and corkscrews. But just like an old-fashioned wooden coaster, the thrills come from the accelerations created when other forces overcome the effects of inertia. If you were blindfolded, you'd have a hard time telling when you were upside down. But it's hard to impress today's thrill seekers, and roller coaster builders are always looking for ways to make bigger and better rides. The Big Shot can go from 0 to 108 miles an hour in 3 seconds. It's an express elevator to the terror of going straight down. How does the Big Shot accelerate so fast? The Big Shot uses a system of compressed air pulleys and guide wheels to send riders to new heights. The same system cushions you at the end of your 20-meter free fall. Despite all the technology, the ride is really just a series of accelerations and inertial effects. They may try to exploit the laws of physics, and they may try to challenge the laws of physics, but roller coasters can't change the laws of physics. Gravity, potential and kinetic energy, speed, inertia, and acceleration will always be part of the equation.
You've been given all the information. Now it's your turn to discuss the questions. Take a moment to talk about the following.
How is energy converted from one form to another?
What forces keep a roller coaster from flying off its tracks?
We hope you've enjoyed this assignment discovery journey into weight and energy. If you'd like to learn more about what you've just seen, go online or check out these books at your local library.